In this video, I'm going to show you how to make a sampling distribution using StatKey. And so this is going to be the material from section 3.1 in the book. And so if you'll look right here in StatKey, it says sampling distributions. And then to the right, it has the option for mean or proportion. So if you're going to make a sampling distribution in StatKey, we're going to be in this section. And so let's first start out by looking at a mean. So we click on mean. And so remember, when we create a sampling distribution, the idea is that we've got population data, and from that population data, we're going to take lots of samples. And then for each of those samples, we're going to calculate a statistic. So since we're working with means, from each sample, we're going to calculate a mean. And then we're going to plot each of those means. And what this does for us is this is going to give us an idea of how the statistic or how the mean behaves from sample to sample. So first of all, looking here, StatKey has different pre-built-in data sets. And so, for example, we could look at the statistics grad school data set. Now notice nothing's popped up yet, and that's because we haven't taken any samples. So we're considering this to be population data. We could click on show data table to actually see what the data looks like. We could also enter our own data, just like we have before, by clicking Edit Data. So now let's actually look at how to create this sampling distribution. Well, the first thing you need to do when deciding on creating a sampling distribution is to know what size samples you're going to take. And so you'll notice here it says choose sample size of n equal. So you could click here, and you could change this to be whatever sample size you want. But remember, we're taking samples from a population. This particular population only has 82 data points in it. So the biggest sample that you could take here would be 82. So let's say we're going to take samples of size 20. So I click OK. Now what I'm going to do is we could generate one sample. So what this is going to do is this is going to take a single sample of size 20 from the population. It's going to calculate the mean of that sample, and it plots the mean right here. Now looking to the right, what is going to happen is notice in the population, this is always going to stay the same. This is the population data for this entire data set. It tells you how many data points, the mean, the median, and the standard deviation. Now the plot below, this is the data from that sample of 20 we just took. And so notice we've got n equals 20, and we've got the mean, median, and standard deviation from this sample. And also notice if we hover over it here, we can see that this data point goes with this right here. Now let's take a second sample. So we're going to generate one sample again. So notice this time, this sample had a different mean. And notice if I hover between the 2 points, the sample information here will change because these are means from 2 different samples, but the population data remains the same. Now, generally, when we create sampling distributions, we need to generate lots of samples to see how the statistic behaves. So we can go ahead and generate 1,000 samples, and StatKey will do this for us. We could generate another 1,000 and another. So notice here what we've got is we had our 2 original samples, and then I just generated 3,000 samples. So we've got 3,002 dots on this plot. Each of these dots represents a statistic from a random sample. And so again, if we kind of hover over the dots, notice the information down here changes. And what that's doing is that's telling us the information from each of these samples. So each of these dots represents a statistic taken from a different sample. Now we saw in class, whenever we create sampling distributions, remember that they should be approximately bell-shaped. This one is approximately bell-shaped. The center is at 53.476. We also learned that the center of the distribution will be very close to the parameter. And remember, in this case, the parameter is the mean of the population. So if we come up here to the population information, notice that the mean is 53.537. And so the mean of this distribution, the center of it, is very close to the true value of the parameter. So that matches. The other thing to remember that the standard deviation of this distribution is equal to the standard error. So if we look up here, notice it gives us the value of the standard error, which is 7.208. So again, this sampling distribution, how it was created was we started out with population data. Here's the summary of the population data. And then we took lots of samples of size 20 from this population data. For each of the samples, we calculated a statistic. And so that's what each of these dots represent as a statistic. And in this particular case, we're working with a mean. And so as we go through here and highlight these, we can see how the sample changes. Not all the samples are the same, so not all the statistics are the same. But by doing this a whole bunch of times, we can get a visualization of how the statistic changes from sample to sample. Now, if we go back to StatKey, notice under the sampling distribution, we already looked at the mean. Now let's look at the proportion. You'll notice that the proportion looks very similar. So we've got different data sets that we could choose from. So let's just choose one of them. Now, what's different here is when we look at the original population data, since we're working with proportions, remember this is categorical data, so we're not going to have a mean or a standard deviation. Instead, we're just going to have the proportion from the population, and this is our parameter. This is our population proportion. Now we could edit the proportion, so let's say we wanted to work with a different data set where we knew what the true population proportion was. We could enter it here, or we could enter some different raw data. Just like with the mean, we could take different sample sizes. So for this particular case, we're going to stick with the size 20, but we could change that. And so just like before, now what we're going to do is generate some samples. So I could generate one sample. What this is doing is it's saying, all right, if you have a population that has proportion 0.256, we're going to take a sample of 20 from that population, and this is our sample information. We found that of our sample size of 20, we had 5 successes, so our proportion is 0.250, and we'll see that that's pointed here. We could take a sample, and we see in the second sample, our statistic changed a little bit, and this is what we expect to happen. And again, if I move from statistic to statistic, you'll notice that that sample proportion will change. Now, just like before, I'm going to go ahead and generate a bunch of samples. Okay. So notice that our sampling distribution, again, it's approximately bell-shaped. It's not perfect, but it is approximate. It peaks very close to the parameter, because remember the parameter, our population information in this case, was 0.256, and it peaks very close to 0.256. And then again, the standard deviation of the sampling distribution is equal to the standard error. So if you look right here, here is your standard error. That is equal to the standard deviation of this distribution. So again, what the sampling distribution is doing for us is it says, all right, if you start with population information and you take a whole bunch of samples from that population, and for each sample you calculate a statistic, so in this case we're calculating a proportion, and you plot all of those statistics, then you're going to get an idea of how the statistic behaves from sample to sample. And we can visualize that using this dot plot.